Today we're going to be looking at section 6.4, hypergeometric probability distribution. We have a few things to note before we get started. It wants you to review the classical method, independence, multiplication rule, rule for counting, and combinations. So we have a few objectives. The first, determine whether a probability experiment is hypergeometric. And so you have some reading and they let you know a little bit about it. Here's the criteria for hypergeometric probability. It says a probability experiment is said to be a hypergeometric experiment provided the finite population to be sampled has n elements. So that tells you that you don't have an unlimited amount of objects that we're going to be testing. We have a finite, accountable set. For each trial, the experiment, there are two possible outcomes, success and failure. There are exactly k successes in the population. So there's two groups, one that we desire, one that we don't. The example I like to use is the lottery. There's a bunch of numbers that you choose from. There's going to be a certain few numbers that are correct. And you will know that there's, like, I think in some lotteries there's 3, some there are 5. Depends on which one you play. But there'll be a certain set of numbers that you want to get. Those will be the successes. Everything else will be a failure. A sample size of n is obtained from the population of size of big N without replacement. So you're going to take a small sample. You're trying to see how many of those numbers that you chose actually were successes. Here's the notation that we use in probability. We got a population size of big N, a sample size of little n. There are k successes. I usually refer to that as special k. There used to be a serial named special k, so those are the ones we're interested in. We are going to let the random variable x denote the number of successes in the sample of lowercase n. So x must be greater than or equal to the larger of n minus n minus k, and must be less than or equal to the smaller of n or k. And so you'll kind of see that as we begin working on problems. So you got some examples here. I would encourage you to read over those. Some history on how this was come about and some of the people that researched this. Here's your objective 2. You're going to compute probabilities of hypergeometric. We'll be doing StatCrunch with this, but here is the formula. You have the group of interest, which is k, and then how many actual successes we have from there. You have your population size, and you take away the special group, so that tells you you're kind of like separating your group into right selections and wrong selections. So everything else that is not correct will go into the other group. And then from your sample size, you're going to subtract the number of correct choices, so you know how many you got wrong. And then you have your total possible sample size selections on the bottom. So your big N, choose your little n. And then they kind of explain the logic behind this method. And you have some examples showing how to compute it using the formula. But again, we'll be doing it with StatCrunch. So I have a couple examples, several examples that they're showing you. And then we have objective 3. We're going to compute the mean and standard deviation. So mean and standard deviation are these very strict formulas. So the mean is just n times k over big N. Okay, so you just do that, you get the mean. Standard deviation a little bit more complex. You have to take the square root of big N minus little n divided by big N minus 1. And then you're going to multiply that by the mean. So that's this n times k over n, same thing here. And then you're going to multiply that by big N minus k over big N. And all of that is under the square root. And they are denoting what each symbol represents. Little n, sample size, k is success, the number of successes in the whole population, and big N is the size of the population. And then you have some examples showing those and interpreting those. And then they show you how to do it with technology. So this is if you're using a calculator, if you use Minitab, if you use Excel, and StatCrunch is the one that we'll be doing. We'll be going to Stat Calculators, go to the hypergeometric formula, and then input the variables. Now in StatCrunch, what you want to note is that the population size, they use the letter little n, and for the sample size they use m. So they don't use capital, they use the lowercase n, and then they use m. And then the number of successes, they still use k. So those are things you want to be aware of. All right, with that, we're going to jump into the problems and start working some of those.